Welcome to our review on electronic structures. So the first thing we need to know about is when we're looking at the periodic table, then there are two terms we should know: period and group. When we're talking about the periods, those are the horizontal rows going from left to right, and a group is the vertical columns going from the top to the bottom. When we're asked about the electronic structure, what we're actually being asked about is how the electrons are arranged in the atom. And what we actually need to understand here is that there's one really important phrase that's going to be thrown around when talking about electronic structure, and that is the outer shell. Now, the outer shell is the outermost occupied shell of an atom. The shell closest to the nucleus will always have the lowest energy level, and that energy level increases the further from the nucleus you go. One of the good things about chemistry, you get a lot of rules. And if you learn the rules, chemistry becomes simple. So when we're talking about electronic structures, we need to remember the rules of how many electrons can fit in each of those shells. So the first shell, the one closest to the nucleus, can hold up to 2 electrons. The second and third shells can hold up to 8 electrons each, and the fourth shell can hold up to 18 electrons. One of the things they could ask you to do is to draw the electronic structure of any given atom that they choose. The one thing they're not going to do is pick one that has a ridiculous number of electrons. They're going to pick probably one of the first 20 elements here. So to give you an example of how we do this, I've given you lithium on the left there. So lithium on the periodic table has an atomic number of 3, so that tells us it has 3 electrons. So if we think back to our rules, we know that the first shell, the one closest to the nucleus, can hold 2 electrons. So we've drawn our circle around the nucleus and we've put 2 dots representing those 2 electrons. Then we have to go to the next shell, that second shell, because we have one more electron, and in it goes. So once you've drawn that diagram, the last thing you need to do is to write the electronic configuration. And it's really easy how we do that. However many electrons are on the first shell, write that number, put a comma. However many are on the second shell, write that number, put a comma, and continue until you run out of electrons. Once you actually have those numbers, it actually tells you a lot about this chemical. Because what we can actually deduce just by looking at those numbers is the group number, the period number, and the atomic number. So the group number is just the last number in that line. So in this case it's a 1, so lithium is in group 1. The period number we get from counting how many numbers there are. In this case we've got 2, so there's a 2 and a 1, so 2 numbers, which tells us it's in period 2. And then if we add them together, the sum of those numbers tells us the atomic number, so the number of electrons. The reason we're concerned with the electronic structures of different atoms is because the chemical properties of any particular element will depend on the number of electrons it has. And the way that that chemical reacts is going to be determined by the number of electrons in the outer shell. As we've just said, any of the electrons that have a 1 as their last number, so a 1 in their outer shell, they're all in group 1. Now, because they've all got 1 electron in their outer shell, all of the elements in that same group react in a similar way. So 1 electron is going to react a certain way because the 1 electron puts them all in group 1, all of group 1 react in a similar way. Hopefully at the end of this video we can recognise the periods and the groups on the periodic table. We can also recall the rules we need for drawing electronic structures, and we can draw the electronic structures of any particular element and work out what each of those numbers represents.